Students, the sun is visible to us about 2 minutes before the actual sunrise and about 2 minutes after the actual sunset, and it all occurs due to the same phenomenon, which is atmospheric refraction. The apparent flattening of the sun's disk at sunrise and at sunset is also due to atmospheric refraction. So here is another animation which explains advanced sunrise and delayed sunset.
Atmospheric refraction.
Let us see it.
We've observed some natural phenomena in our daily life, such as the apparent random wavering or flickering of objects seen through a turbulent stream of hot air rising above a fire or a radiator. The twinkling of stars is a similar phenomenon. This wavering is thus an effect of atmospheric refraction, refraction of light by the Earth's atmosphere in our local environment. Let us discuss about them. Twinkling of stars. The twinkling of a star is due to atmospheric refraction of starlight. The scientific name for the twinkling of stars is stellar scintillation or astronomical scintillation. Stars twinkle when we see them from the Earth's surface because we are viewing them through thick layers of turbulent, moving air in the Earth's atmosphere. Stars, except for the sun, appear as tiny dots in the sky. As their light travels through the many layers of the Earth's atmosphere, the light of the star is bent, refracted many times, and in random directions. Light is bent when it hits a change in density, like a pocket of cold air or hot air. This random refraction results in the star winking out. It looks as though the star moves a bit, and our eye interprets this as twinkling. Stars closer to the horizon appear to twinkle more than stars that are overhead. This is because the light of stars near the horizon has to travel through more air than the light of stars overhead, and so is subject to more refraction. Also, planets do not usually twinkle because they are so close to us. They appear big enough that the twinkling is not noticeable, except when the air is extremely turbulent. Stars would not appear to twinkle if we viewed them from outer space or from a planet or moon that didn't have an atmosphere. Apparent position of sun. Because of atmospheric refraction, we do not see the sun or the stars in its true position except when it is directly overhead. As a ray of light from the sun enters Earth's atmosphere at B, it continuously bends towards the radius of the Earth. The ray of light will reach the observer at O, as if it had come in the direction AO instead of in its true direction BO. Consequently, we do not see the true position of the sun. It is due to atmospheric refraction that the sun is visible before actual sunrise and